exploding mobile data traffic demand is making the carriers escalate their build-out of the wireless RAN infrastructure, and that's no surprise to anyone in this room. In order to do that, of course, you need to go to the newer 4G technologies, and what's needed is an all-IP digital transport. So when you ask, is fiber to the antenna necessary? Well, the answer to that is certainly. And some people, a lot of us at 3M, believe that eventually we'll have basically fiber plus wireless networks. You know, someday we may call that the Fi-Wi, for example. That might be a new term we get used to. So the fiber is going to be needed for fiber to the cell site for backhaul. Fiber is future-proof, can support terabytes of data, and of course fiber to the antenna, which is really fiber to the remote radio head, and that's going to be needed as well. Eventually, we're going to see an evolution of the base station architectures going from the traditional integrated approach with the 2G and 3G architectures to the distributed base station approach, which I'll talk a little bit about in the next couple of slides. And eventually that will even migrate to the compact base station, which companies like Mindspeed and Freescale are working on those chips to enable a miniaturization of the base station architecture. And that will be the future. Today what's happening is a migration to the distributed base station. And this means that you have now the baseband unit located at the bottom of the tower, and you place the remote radio head at the top of the tower. The fiber is replacing the coax up the tower mast, and of course you need power also, so you're running the power conductors up the tower, and that can be either with the fiber or separate in different scenarios. This is what it looks like, just a simple pictorial. On the left you have the traditional base station, which includes all the functions of the integrated base station with coax feeders, which are heavy coax from 7/8 inch to 2 1/4 inch size coax feeders up the tower. And then we're migrating to the distributed base station in order to optimize the macro network, and that includes all the baseband functionality at the bottom of the tower. You have fiber optic and power that runs up the tower to the remote radio head, which still does the analog to digital, digital to analog conversion, and the RF amplification to the antennas. And of course that's where you have the short coaxial run to the antennas. Drivers for the adoption of fiber to the antenna, fiber to the remote radio head, are going to be signal integrity. So for the quality of the network, it's important that fiber is used on the tower to minimize the noise that's introduced by the attenuation of the coaxial cables. So that's one big reason. Another is the energy efficiency. Of course, that's what's really driving the changes, and that's because the power consumption moving to the distributed architecture can save as much as 50%. I've heard everything from 50 to 20%. But in any case, it's going to be a couple hundred or a few hundred watts of power per base station to move to this distributed architecture. So that's one of the big reasons. Of course, the signal is lost going up the coax, up the tower, and so you have to have more amplification with the tower-mounted amplifiers, and you waste a lot of the signal, so it's not very efficient. In addition, at the bottom of the tower, the typical equipment that's at the bottom of the tower is not very efficient as far as power, so it requires added air conditioning, and even that adds to more power consumption. So those are two of the primary drivers. We have an entire tower platform solution supporting all the different methods of fiber to the antenna.